This video is for lesson 8-1, day 1. It's the solutions to the book problems. The first skill is to check if an ordered pair is a solution to an equation with two variables. And the method for doing this is to substitute the values from that ordered pair into the equation to see if you get a true equation. Now, the other skill that will be in this lesson is to determine solutions to a two-variable equation. The method for doing this is to solve the equation for the variable y. Then use different numbers in place of x. When you plug those numbers in for x and calculate the resulting answer for y, you end up getting solutions to the equation. So skill number 1, here's an equation with two variables. 5x plus 2y is equal to 23. The first ordered pair that we're asked to check is 3, 4. So the first number in the ordered pair is the value of x. The second number is the value of y. It's always alphabetical order. So we want to try 3 in place of x and 4 in place of the letter y. And what we're wondering is, does this equal to 23? And if it does, we'll say yes. And if it does not, we'll say no. So 5 times 3 is 15. 2 times 4 is 8, and 15 plus 8 is 23. So this is yes. Now, still question 1, the same equation. What about the ordered pair 7, negative 6? Let's try those. So in place of x, put 7, and in place of y, put negative 6. And what we're wondering is, does this equal to 23? Well, let's find out. 5 times 7 is 35. And 2 times negative 6 is negative 12. 35 subtract 12 is 23. And so this is yes. So you see the technique, right? To decide if an ordered pair given to you is a solution to an equation. Substitute the values in place of the letters, and then determine if the left side is equal to the right side. So number 3, the first number will be for A, and the second number will be for B, because it's alphabetical order. So 3 times 3 minus 2 times negative 2, and we're wondering, does this equal to 13? Well, let's find out. This is 9 plus 4, which is 13. And so this is yes. Now, what about B? What about this other ordered pair? So 3 times the 5 minus 2 times the negative 1. Does this equal to 13? 3 times 5 is 15. Negative 2 times negative 1 is plus 2. And that makes 17. So using these two numbers does not create a solution to the equation. This is no. Number 5, 2 times, fill in 5 for x, and then 3 times, fill in 1 for y, and then we're wondering, does this equal to 13? So this is 10 plus 3, and that is 13. This is yes. Now what about this other ordered pair? So 2 times, fill in the 11, plus 3 times, fill in the negative 3. Does this make 13? So this is 22 minus 9, and 22 minus 9 is 13. This is yes. Number 7, in place of A, fill in the 1/3 from the ordered pair. In place of B, fill in negative 5/2 from the ordered pair. And we're wondering, does this make 11? So 3 times 1/3 is 1 minus the 4 and the 2 reduced to a 2, and 2 times negative 5 is negative 10. This is a plus 10. and this does make 11. Now our second ordered pair, 3 times -5/3 minus 4 times -4. Does this make 11? So the 3's reduced to -5, and -4 times -4 is +16, and this adds up to 11. This is yes. Number 9, in place of x, fill in the 4. In place of y, fill in the -1. And we're wondering, does this make 15? 4 squared is 16, minus 3 times -1 squared is 1. So this is 16 take away 3, which is 13, not 15. This is no. Okay, question B. In place of x, fill in -4. In place of y, fill in 1. And we're wondering, does this make 15? So -4 squared is 16. 1 squared is 1. And this is 16 take away 3, which is 13. And this is no. Number 11, here we have an equation with s and t. Alphabetically, s comes before t. So this is the s, this one's the t. Always alphabetical order with an ordered pair. So we have 4 times -1/4 gets filled in for s, -3 gets filled in for t, and does this equal -3? Let's find out. The 4's reduce, creating -1, and -1 times -3 is 3. That does not equal -3, so this is no. Now the second ordered pair, 4 times, fill in the number for s, fill in the number for t. Does that equal 0? Yup, if you multiply these three numbers and one of them's a 0, then you do get 0. So this is yes. Okay, now we're to the second skill. We're not given ordered pairs that we're supposed to check if they're answers. We have to find the answers. We have to find the ordered pairs. Okay, now to keep your work organized, I recommend that you create an XY table. It's a chart with 2 columns. The first column is called X. The second column will contain Y values. So this little diagram here, this is called an XY chart or an XY table. This is equivalent to having ordered pairs with the 2 numbers with the parentheses. Now the technique is to take the equation and to solve it for Y, right? Get the letter Y alone. Solve for the Y. To get the letter Y alone, we need to take away the 2x from both sides. This is going to make y equals 6 take away 2x. Now, these are not like terms, so don't say like 4x or something. The best you can do is make a binomial, 6 take away 2x. Then, we're given a domain. X must be a whole number. It can't be a negative number. It can't be a decimal or a fraction. X has to be a whole number. The lowest whole number that exists is 0. The next whole number is 1. The next whole number is 2. The next whole number is 3. The next whole number is 4, and so on. Now, what we want to do once we decide what numbers to try in place of x is to actually substitute those values into our equation and figure out what we would get for y. Okay, remember, you always find y by doing 6 take away 2 times x. Well, what if x is 0? What do you get? What's 6 take away 2 times 0? That's 6. Now we're told in the directions that the letter y must also be a whole number. Well, 6 is a whole number. So the first row of our chart contains an answer, 0, 6. That's one of the answers. There could be more. So what if x is 1? So to find the value of y, we're going to go 6 take away 2 times x. But what if x is 1? What is 6 take away 2 times 1? That makes 4. And that's a whole number. And so another solution is 1, 4. So do you see what's going on? We're going to keep going like this until we get a number for y that isn't a whole number. So what if x is 2? So 6 take away 2 times 2. This makes 2. And so another answer is 2, 2. When x is 2, y is 2. One more time. Y equals 6 take away 2 times 3. This makes 0, and 0 is a whole number. 0 is the smallest whole number that exists. So our solution is when x is 3, y is 0, 3, 0. Now, what if x was 4? What's going to happen? We'll have 6 take away 2 times 4. What does that make? 2 times 4 is 8. 6 take away 8 is -2. That's not a whole number. So we don't want to include 4, -2 as a solution because it doesn't create a number that's in the domain for y. And hopefully you notice that if we continued increasing the value of x, that's just going to make y another negative number. And so these 4 ordered pairs are our solutions to number 13. So check out how that was done. The first step was to solve for y. So in this next one, take away 3x, take away 3x from both sides. That gets the y term alone. And over here we have 8 minus 3x. Those are not like terms, so you can only do a binomial. Then divide by 2 in all places. So we get y is equal to 4 minus 3x over 2. Now step 2. Step 2 is where you make an xy table so that you're being organized. Now, what is the lowest whole number? It's a 0. What is the next whole number? 1. What's the next whole number? 2, 3, 4, 5, and so on. We're going to have to decide when to stop. And we're not going to know that unless we pay attention to the outputs that we get for y. Once we notice that our outputs keep making numbers that are not whole numbers, then we'll stop. Okay, so to get y, we figured out that we're going to go 4 minus 3 times x. Well, what if x is 0? All over 2. What does this make? 3 times 0 is 0. 0 divided by 2 is 0. And 4 take away 0 is 4. And that is a whole number. So 0 for x and 4 for y is one of the solutions. Now, what if x is 1? What's going to happen? So we have 4 take away 3 times 1 all over 2. What's this going to make? 3 times 1 is 3. 3 divided by 2 is 3 halves, or 1 and a half. And 4 take away 1 and a half is 2 and a half. That's not a whole number. That's not in the domain for y that we're given in the directions. So we're not going to get an answer when x is 1. Well, what about when x is 2? So y is always equal to 4 take away 3 times the x divided by 2. What's this going to make? The 2's cross out, leaving the 3, and 4 take away 3 makes 1. And so another answer is 2, 1. Now, what will happen if x is 3? Will we get a whole number? Or should we stop because we're not going to get any more whole numbers for y? Right? Pay attention to what's happening from row to row. From our first row, it went from 4 to 3.5 to 2.5. So it's decreased by 1.5. From here to here, it has decreased by 1.5. Right? From here to here to the next one, it's going to decrease by 1.5, which is going to create a negative number. And if we use even larger numbers for x, we're just going to get more negative numbers for y. So our solutions are these two ordered pairs. Only these two ordered pairs are solutions for number 15. Okay, number 17. Step 1. Transform the equation so it's solved for y. So you need to subtract the 3x from both sides. That makes 7y is equal to 7 take away 3x. Now divide by 7. 7 divided by 7 is 1. And over here we're going to get 3x over 7. Okay, now step 2. Step 2 is where you are going to find your answers, and to be organized about it, make an XY table. We're only allowed to use whole numbers for x, and the first whole number that exists is 0, and the numbers increase like 1, 2, 3, and so on. So if x is 0, what would we get as an output for y? 1 take away 3 times 0 over 7. What's that make? 3 times 0 is 0. 0 divided by 7 is still 0. And 1 take away 0 is 1, which is a whole number. So 0, 1 is an ordered pair. Now, let's put some thought into what's going to happen like if we try 1 as the next whole number. This would look like y equals 1 take away 3 times 1 over 7. When we work this out, are we going to get a whole number? Right, 3 times 1 is 3. 3 divided by 7 is the fraction, 3/7. 1 subtract 3/7 is 4/7. That's not a whole number. If x was 2, this would become 3 times 2, which is 6. 6 over 7 is a fraction. 1 subtract 6 over 7 is 1/7, not a whole number. If x was 3, so in this spot right here, if this was a 3, it would become 9 over 7, which is still a fraction. Okay. The next wise choice for x is to go all the way to choosing 7 to see what happens. So here's what it's going to look like if you choose 7. The 7's cross out. That's why I went all the way to 7. And we're left with 1 take away 3, which is -2. Negative numbers are not whole numbers. Now, is there any point in choosing even larger numbers for x? That would be a waste of time. The only answer to this question that fits the domains is 0, 1. Okay, number 19. The first thing you do is you solve the equation to get the letter y alone. So first step, subtract the x. Second step, divide by 2. So 9 over 2, take away x over 2. The other way you could write it is you could do 9 take away x over 2. These are the same thing. All right, so either one's fine. You just decide which way you like better. Okay, now step 2. Make an XY table. The first whole number is 0. Now, when we use 0 as an input for x, what do we get as an output for y? We would have y equals 9 take away 0 all over 2. And this makes 9 over 2, which is 4.5 or 4.5 as a decimal, but it's not a whole number. So using 0 for x doesn't create a solution to the equation that fits our domain. But what about if we use 1 for x? What's going to happen? So we have y equals 9 take away 1 over 2. This makes 8 over 2, which equals to 4. And that is a whole number. So 1 comma 4 is a solution to the equation. Now, do you see any patterns here so that we're making wise choices for x? Should we use a 2 for x? No, what would happen if we did use a 2 for x and we worked out the math is this would result in 3.5, which isn't a whole number. However, if we used 3 for x and we worked out the math, now we're going to get 3. And that is a whole number. So 3 comma 3 is a solution to the equation. All right, think about patterns. What other numbers for x are going to create whole numbers for y? And when should you stop for x so that you don't continue on and end up getting negative numbers for y? Right? So it looks like that x needs to be an odd number. So I think another answer for x would be that you could use 5, and that when you work the math out, you're going to get a 2 for y. The next odd number is 7, and when you work the math out, you're going to get a 1 for y. And the next odd number is 9, and when you work the math out, you're going to get 0 for y, and that's the smallest whole number. So if you keep going, if you use an 11, you would get a negative 1 for y, and that's not a whole number. And so the answers are these 5 ordered pairs. Now number 21, step 1. Transform it so the letter y is alone. You have to divide by the x. You're going to get y equals 4 over x. Now step 2, that's our xy chart. The first whole number that exists is 0. To find the answer for y, you fill in 0 for x. Now earlier this year, what did we learn about division by 0? Right, that is undefined. That is where we would get like restricted values, right? We would say that you're not allowed to have 0 in the bottom of a fraction, therefore x is not allowed to be 0. So if x is not allowed to be 0, then certainly we can't have an answer that has x is 0. What if x is 1? So we have y is equal to 4 over 1, which makes 4. And so one answer is 1 comma 4. What if x is 2? We have y equals 4 over 2, which equals to 2. So another answer is 2 comma 2. What if x was 3? We have y equals 4 over 3. That's a fraction, not a whole number. What if x is 4? What would you get for y? So we'd have 4 over 4, which is equal to 1. And so 4 comma 1 is an answer. Now, should we keep going? Is there any number that you could fill in for x that would make y turn out to be 0? There's not. If y is equal to 4 divided by x, there's never going to be a number that you could put in there and ever get that to be equal to 0. And so these 3 answers are the solutions to the equation. Number 23, step 1. Solve it for y. To get y alone, you have to divide by the 3 and the x. And by the way, 9 divided by 3 is reducible, and so it'd be better just to say 3 over x. Okay. Now, step 2. This is where we're going to make our xy table. What happens if you try 0 for x, but there's a x in the bottom? Right, this is going to turn out to be undefined. Okay, the next number you might choose for x is 1, and so y is equal to 3 over x, and so this makes 3, which is a whole number. 1 comma 3 is an ordered pair. Should we use 2? What if you have 3 over 2? That's not a whole number. But what if you use 3? So you have y equals 3 over 3, which makes 1. That's a whole number. And so when x is 3, y outputs as a 1. Is there any way to have y come out as 0? No, there's not. There is no way to make this fraction turn out to be equal to 0. If you start with a 3 in the top, 3 divided by something makes 0. No, there's no such number. And so these two ordered pairs are the solutions to the equation. Okay, number 25. What is step 1? Have you got it figured out yet what the first thing is? You want to solve for y. So first thing is subtract the 7. 23 subtract 7 is 16. Then divide by the x. You get 16 over x. Now step 2. Have you got it figured out what step 2 is? Step 2 is to make an xy table. Should we use 0 for x when the x is in the bottom like that? Nope, 0 is a restricted value. Is 1 a good choice for x? If you use 1 for x, do you get a whole number for the y? Yes, you do. You get positive 16. That's a whole number. And so 1 comma 16 is an answer. Is 2 a good choice for x? What if it's 16 over 2? Yup, that makes 8. 2 is a great choice for x. So 2 comma 8 is an answer. Now what about 3? Would it be appropriate to use 3? Because we'd end up getting 16 over 3, and that's not a whole number. What about 4? This would be 16 over 4, which makes a whole number. And so when x is 4, y is 4. Now, 5 would not be a good choice. 16 divided by 5, that's not a whole number. 6 is not a good choice. 16 divided by 6, nope, not a whole number. What is the next number for x that's a good choice that's actually going to work? It needs to be 8, because then it is 16 divided by 8, which makes 2. All right, it seems like there should be one more number for x that's going to work out nicely. All right, what if x was 16? Then y turns out to be 1. And so these 5 ordered pairs are the solutions. Okay, number 27, step 1. Solve for the y. The first thing you need to do is to subtract 5 from both sides. That's going to make 10. Now to get y alone, you have to divide by its coefficient, which is the 2x. The 2x is right in front of the y, so you've got to divide by the 2x. Now the letter y is alone. Does this reduce? What about 10 over 2? Can you do anything? That makes 5 over x. Okay, we now have our formula that we're going to use to find the values of y. We're going to use the formula that y is equal to 5 over x. Let's make an xy table. 0 is a restricted value, but I think that x could be 1. So this is y equals 5 over 1, which makes 5. And this is the ordered pair 1 comma 5. Now, should we use 2? What's 5 divided by 2 make? Not a whole number. Should we use 3? Should we use 4? What's the next number you can think of that when you put it in for x, it's actually going to work out to a whole number? That would be to use a 5. Because this would be y is equal to 5 divided by 5, which does make a whole number. And so another ordered pair is 5 comma 1. Here are the two answers to the equation when we're given the domain restrictions that we can only use whole numbers. Okay, number 29. We want to get the y alone. And in front of it, right, multiplied in front of it is the x plus 2. So to get the y alone, we have to divide by the x plus 2. There's our formula for y. Now comes our xy table. what happens if x is 0? What's going to happen when you figure out y? So y is equal to 5 over 0 plus 2, which is 5 over 2, which is not a whole number, right? 5 over 2 is 2.5 or 2.5, not a whole number. What about when x is 1? Is it going to work out to a whole number? Right, so we have y is equal to 5 over 1 plus 2, which is 5/3. Nope, not a whole number. Okay, what is a number that when we put it in for x, it's actually going to work out nicely and make a whole number? Can you think of a number for x that would work? I think that x needs to be 3. Because then we have y is equal to 5 over 3 plus 2. And that makes 5 over 5, which is equal to 1. And so our solution is 3, 1. Now, again, think about whether there's any way to make y turn out to be 0, because 0 is a whole number. So is there any way that you can get y to be 0? You can't, not with a fraction that has a 5 in the top. There's never going to be a number that you can plug in for x and work this out and ever get it to be equal to 0. So we only have one solution to that equation. And number 31, the very last one, we want to get the letter y alone. Well, next to the y, it's not shown, there's like a timesing dot here, right? So the opposite thing of timesing is division. To get y alone, we divide by the 4 minus x. Here's our formula for y. Now we'll make our xy table. What happens if x is 0? So y is equal to 4 over 4 minus 0. Does this work out nicely? This is 4 over 4, which makes 1. 0, 1. What about if x is 1? What's going to happen? So we have y equals 4 over 4 minus 1. This makes 4 over 3. That is not a whole number. 4 over 3 is like 1 and 1/3, not a whole number. What about if x was 2? Is it going to work out? Let's try it. So y equals 4 over 4 take away 2. This is 4 over 2. And this is equal to 2. So 2, 2 is a solution. Are there any other numbers that you could put in for x and it's going to turn out to be a whole number? Can you think of any other numbers? What happens if x is 3? So we have y equals 4 over 4 minus 3, which makes 4 over 1, which makes 4. And so 3, 4 is an answer. Should we keep going? Is there going to be anything else? What happens if x is 4? Nope, you can't have x is 4. 4 is restricted. Remember that the denominator cannot be 0. And so in this one, that means x cannot be a 4. So you can't even use 4. It's not even allowed to use 4. Should you use 5? What would happen if you used 5? What would happen in the denominator? You'd have 4 minus 5, which is negative 1. So now you're starting to get negative numbers for y, and those aren't whole numbers. And so number 31 has 3 answers, and here they are.